Good morning, everybody, or I should say good afternoon. For me, it's early morning, and unfortunately, I'm recording this from Dayton, Ohio, where I'm doing some training right now. I wanted to introduce you today to essentially the hardware that we're going to work with in this classroom. And one of our first victims is the Intel Galileo. The Intel Galileo was, in my opinion, and with some evidence to back it up, the response that Intel had to the growing popularity of the Raspberry Pi, which was essentially based on the ARM processor. Now, the ARM processor is a fabless processor. You'll see that this is Intel's Galileo right here, and it uses the Intel processor, specifically, that you'll see in your handout, and that essentially, this is the reason for the entire Intel Galileo. One of the things that I think Intel did very smartly was they went to the Arduino organization, which is essentially committed to open hardware, but mainly just for the purposes of getting people's hands on hardware and electronics to teach basic electronics. And the biggest problem with the Arduino platform is it's not smart enough. It is basic embedded systems. Embedded systems have their software committed to them, usually through a PC, and not with their own operating system. The PC that is used to burn to the chip, or an EEPROM, will take that software and go on ahead and then run against whatever input and output requirements are programmed into it. The Intel Galileo was designed to work with Arduino's existing pinout structure, meaning these pins over here dedicated to digital pulse wave modulation, and these pins down here dedicated to analog as far as different I/O types of elements. Now, again, the primary concern was Intel, in my opinion, wanted to have their processor on these credit card sized computers, but they also wanted to add a few things, and that's one reason that the Intel Galileo, as you will see if Chris Carroll would pass out those boards or show you those boards, or I will show you next week when I get to back to Indiana. The Galileo is the largest of the three boards I want to show you, and the purpose in doing this is to go on ahead and give you the opportunity to at least know what the ground you're going to cover is. And the ground, unfortunately, requires the use of a USB microscope to show you around, because these are small components. To give you an idea, that is your Ethernet jack. Notice that right there. You see? So an Ethernet jack looks like a gigantic building on this campus of board that you have here. But I'm just going to show you around and give you an idea of what the lay of the land is and why the Intel Galileo is a decent competitor, but you'll also have a document to show that it isn't the same. It has its own pluses and minuses, as does the Raspberry Pi, and as does our third candidate, which unfortunately we don't have copies of for you to work with, which is the BeagleBone. So there's a document that you'll be looking at this week to prepare you for next week when I get back and we start doing a lot more, of course, hands-on, and that is working with the Intel Galileo and the Raspberry Pi to give you the opportunity to work with these devices as the IT people that you are. In other words, you know what an operating system is. You know what it's like to work with a PC, or else you wouldn't be in our program. What we want you to get is the understanding that these devices, having these mini PCs, micro PCs, nano PCs, whatever you want to call them, having these devices embedded into objects relied on single chip architecture that really didn't have the kind of robustness that a microcontroller really does, which is where these are a lot closer to, something along that line. and they give you the ability to run, for instance, the Linux operating system. And to give you an idea, that chip right there, squarely in the center of the screen, as you can see, my pinky will come in here, that right there, that chip, is actually holding 8 megabytes of memory, not that impressive, but a basic copy of the Linux operating system that this board can boot up from. Now that's going to be very unusual compared to all the other boards you see other than the Raspberry Pi. The Raspberry Pi is one of the few boards I've ever seen in this class where the operating system is completely void. It's not on the board at all. You need an SD card in order to run Linux. This board, as well as the BeagleBone, in this case on the chip I just showed you, has Linux already, in a sense, embedded onto the board. However, you can run a full-featured Linux system if, as we go over here, you have one of the improvements, I think, of the Galileo over the Raspberry Pi, which is this micro SD card I/O. See that SD I/O right next to the 5-volt power up here? This board is going to give you the opportunity to use a micro SD card to run your operating system as well. It's relatively underpowered, as you'll find out from the article that you're going to read, but it does not equate to the power it uses. You'll find that most of the devices you see out there run on 5 volts of power. The only difference is this one uses a barrel connector, as you can see here, and that barrel connector comes with the Intel Galileo as part of the package that you can buy that the Galileo is sold with. That's one of the distinctions with the Intel Galileo. You don't have to buy this power supply separately, but it requires that power supply. You cannot power this off of USB independently. Some people would call that, for that reason, they would call this a memory hog. Some of the other things that are kind of neat about the Intel Galileo, it uses the Universal Asynchronous Receiver and Transmitter, or UART. That is not a microphone jack. It looks like it, but it isn't. And that particular UART allows you to terminal into that chip we showed you earlier, which is right there, the Linux chip. In between it, you'll see a couple micro USB plugs, which are pretty nice, jacks. One of them is the USB client, and the other one says clearly USB host. Again, in real life, these aren't as easy to read. Don't get used to this. So the USB client is what it sounds like. If you want this board to be connected to another computer, that's how you communicate with it. You'll notice there are no AV jacks anywhere on this board. It is designed, much like the Arduino, to use the Arduino operating system that you can install on a Windows or Linux, I believe even a Macintosh PC, and you communicate through this USB client port. That, connected to your computer, in addition to the power, allows you to speak to the Intel board. On the other hand, if you want the board to control something using USB, you have a USB host jack. Now, most of what you're going to do that's interesting with the Galileo, and something we're going to touch on in this class that works with both the Raspberry Pi as well as the Intel Galileo, using the same components, we're going to have what are considered different shields put onto these devices. The Raspberry Pi has a different pinout, as you'll see in a minute, but the Galileo has the common, more common to Arduino users, pinout structure, and this will adapt to any Arduino compliant type of board, add-on board that you can plug in, and it fits essentially directly over all of this real estate here. By the way, you've got some RAM right over here and here. Those are your two RAM chips. And of course the serial number, which has been right in front of you. Essentially, the Intel Galileo is going to be worth seeing the alternative to the star of the show, which is the Raspberry Pi. In the interest of size of this video, I'm going to go ahead and stop here with the Intel Galileo and give you the opportunity to digest what you've learned with this separately from the Raspberry Pi video, which will start here in a minute.